All right, let's get right into it. For what feels like a lifetime, our picture of the cosmos has felt pretty solid, almost complete. But what if I told you that our best, most beautiful theory of how the universe works might be on the verge of a total revolution? Now, the most important word in that quote is finally, because for the first time in ages, the universe is, well, it's misbehaving. It's not playing by our rules. And for scientists, that's not a disaster. Oh no, that's the most exciting thing that could possibly happen. It's a sign that we're right on the edge of a huge new discovery. So let's back up a bit and talk about what we thought we knew. For decades, we've had this thing called the standard model of cosmology, and honestly, it was beautiful. It was this elegant theory that explained pretty much everything we could see, from the echoes of the Big Bang to how galaxies clump together. It matched what we saw out there so well, it really felt like we had almost deciphered the entire cosmic code. But then, our technology got better. Our telescopes got sharper, more powerful, and they started peering deeper into the universe than ever before. And that's when these strange little mismatches began to pop up. Things that our perfect theory said should be one way just weren't lining up with what we were actually seeing. At first, you could maybe write them off as small errors, but the more we looked, the bigger those cracks became. We've actually been in this exact spot before in science, and it tends to go one of two ways. First, you've got the Uranus moment. Back in the day, Uranus's orbit was acting weird. It wasn't following the rules. But it turned out the rules, Newton's laws of gravity, weren't wrong. We were just missing something, a hidden planet, which we later found and named Neptune. So the solution was just more stuff. But then you have the Mercury moment. Its orbit was weird too, but no amount of hidden planets could explain it. The solution wasn't more stuff, it was a whole new idea, Einstein's general relativity, which completely rewrote our understanding of gravity. So that's the billion-dollar question, isn't it? Where are we right now? Are all these strange cracks in our theory pointing to a cosmic Neptune, some new particle we haven't found, maybe a new type of energy? Or are we on the verge of a cosmic Mercury, a moment that forces us to throw out the rulebook and come up with a whole new idea about how the universe actually works? Let's dig into the evidence. Okay, so crack number one. Impossible structures. The first major clue that something is seriously wrong comes from the sheer size of things out there. We are finding structures in the universe that are so gigantic, our theories say they just shouldn't exist. Period. Now, to get why this is such a big deal, you have to understand this one foundational idea that pretty much all of modern cosmology is built on. It's called the cosmological principle. It's the basic assumption that if you zoom out far enough, the universe is basically the same everywhere. No weird spots, no special places. It should be uniform and smooth on the largest scales. But what if it isn't? Here's the problem. Our model says that random clumps of matter shouldn't get much bigger than about 1 billion light years across. It's like a cosmic speed limit on size. But we found things like a giant arc of galaxies that's 3 times that big, and a wall of galaxies stretching for 10 billion light years. That's almost 1/10 of the entire observable universe. These things are cosmic monsters, and they are shattering the rules. So why does this matter so much? Well, if the cosmological principle is wrong, it could mean that our little corner of the universe is just a weird spot. We could be like ants living on the single cherry on top of a giant complex cake, thinking the whole cake is made of cherry. All our big, grand conclusions about the cosmos, they might just be based on a local quirk. All right, let's move on to the next piece of this puzzle, crack number 2, a 2-speed universe. And this one is a real head-scratcher. It sounds impossible, but it seems like the universe is expanding at 2 different speeds at the same time. The best way to picture this is to imagine you're driving your car. You look down at your speedometer, and it says you're going exactly 67 miles per hour. But then you look over at your GPS, which uses a completely different system to calculate your speed, and it says you're going 73. One of them has to be wrong, right? But what if you get them checked and they're both working perfectly? That's the exact problem cosmologists are facing right now. So here's our speedometer. When we look at the oldest light in the universe, the faint afterglow of the Big Bang, and we run it through our standard model, it tells us that the universe today should be expanding at 67 kilometers per second per megaparsec. It's a very precise number. But then we pull out our GPS. We directly measure the expansion rate by looking at stars and exploding supernova in the universe closer to us. And when we do that, we get a totally different number, 73. They just don't match. And look, this isn't some small measurement error that we can just brush off anymore. As our telescopes have gotten better, the difference between these two numbers has only gotten more certain. Right now, the odds that this is just some random coincidence are less than 1 in a million. The universe is literally giving us two different answers to the same fundamental question. Something, somewhere in our physics, is broken. This brings us to the third crack in the theory, and it's the newest one. It comes from the most powerful space telescope we've ever built, the James Webb Space Telescope. And what it's finding in the baby universe is shaking up everything we thought we knew about how the first galaxies were born. Remember, telescopes are basically time machines. The farther out into space we look, the farther back in time we see. JWST is designed to peer back into the absolute infancy of the cosmos. And the problem is, it's finding these big, bright, fully formed galaxies that look way too grown up for how early they are showing up. Let's just look at the timeline here. Our theories predicted that the first big galaxies would take a while to get going, slowly building up over time. We expected to see them start to appear around, say, 500 million years after the Big Bang. But JWST is spotting them as early as 280 million years. That is way, way ahead of schedule. It's really like walking into a kindergarten classroom and finding a bunch of fully grown adults sitting at the desks. It just doesn't make sense. These galaxies aren't just big, they're also packed with heavy elements that should have taken billions of years and multiple generations of stars to create. It feels like either the early universe was playing on fast forward, or our whole story about how galaxies form is missing a major chapter. So, let's recap. We have structures that shouldn't exist, a universe that's expanding at two different speeds, and galaxies that are way too mature for their age. It sounds like a total mess. It sounds like a crisis. But in science, a crisis is just about the most exciting thing that can happen. Because a crisis like this doesn't mean we failed. It means the exact opposite. It means our tools, our incredible telescopes, and our clever methods are finally powerful enough to show us the edges of what we know. It means the whole machine of scientific discovery is working perfectly, pushing us beyond the old map and into uncharted territory. This is how science has always worked, really. It moves in these cycles. You start with a period of calm, where a theory seems to explain everything perfectly. But then new data creates a crisis, a period of total confusion. That confusion is what sparks a revolution in thinking, which leads to a new, deeper, and better theory. And then the whole cycle starts over. Right now, we are living right in the middle of step 2. When you put all these cracks and mismatches together, the message is pretty clear. These aren't just little bookkeeping errors. The universe itself is practically screaming at us, telling us that our story is incomplete, that there is a deeper, stranger, and more wonderful reality out there waiting to be discovered. And that brings us right back to our central question. Is the solution going to be a cosmic Neptune, some extra ingredient we just need to add to our model, like a weird form of early dark energy or a new kind of ghost particle? Or is it a cosmic Mercury, a moment that requires a whole new idea, something that changes our fundamental picture of gravity, or dark matter, or reality itself? We don't have the answer yet, but one thing is absolutely certain. The universe is about to get a whole lot more interesting.